Hey everybody, and welcome to part 2 of the Cyclic Oscillation Bundle video by Umbrella Modular. Last time we took a look at all of the 4 oscillating LFO modules. If you haven't had a chance to check that out, take a look. In this video, we're going to take a look at the 2 mixer utility type modules. Now, at the outset, before we get into any of the details, one thing I want to point out, I'm going to alternate between using audio and control voltage as input and output sources, but these modules will work with both. So anything that I show you with one will also work with the other. Let's start by taking a look at the module on the left, the Crossfader. The Crossfader is probably easiest to understand if you hear it with audio. So I've added an oscillator here to the patch. And what I'm going to do is I'm going to patch each of the different waves of this oscillator into the module. Now you can see what I've just done. Up here on the top of the module, there are 4 inputs. And again, these can take either audio or control voltage in. Now down here on the bottom, there are 4 outputs. Let's ignore average for now. We will use that for control voltage. The traditional crossfader behavior we can get by using this all. What all will do is it will crossfade between all 4 of these inputs based on the position here of the knob. So I'm going to pull the knob all the way over to the left. My volume's down. I'm going to bring up all. I'm going to patch that into the output. Let's take a listen. Okay. And as we turn the knob from left to right, so there's triangle, sine, getting into the square, and then finally down to saw. So this works basically like a 4 input, 1 output crossfader. Well, there's 2 other output jacks here that I want to mention. 1, 2 will give you the crossfaded output of 1 and 2. And then as the knob passes that, it will become silent. Let's take a listen. So there we can hear it. We're into the square, and now it's going to fade down. So you can see now that we're over here on 3 and 4, we're not getting anything until we start getting back in that range. Now, likewise, we get the same behavior here. 3, 4 will give you the crossfaded output between 3 and 4, and it will be down to 0 as we approach this range over here. That was a little harder to hear. I'm going to change up the order here just to make that a bit easier. So this is the sine, which is a little harder to hear. We go into the square wave. Now, this last output here, average, will give you the mathematical mean of all of the inputs. So you can hear even with audio, we're getting something a little different there. Actually, let's take a look at that on the scope. Right, so there you can see it's this average of a triangle, a sine, a square, and a saw wave. Now, all of these 3 over here, 1, 2, 3, 4, and all, will all be relative to the position of the knob. Average will always give you the average regardless of the position. As with the other modules in this bundle, there is a control voltage input port that allows us to modulate the primary functionality. In this case, the port labeled CV will modulate the fade position. So I've got the same setup that I did before. We've got 4 audio inputs. You can see we've got the audio output here, the all. We'll take a listen. Okay, so that's what that sounds like. Now I've added the smooth LFO here to the patch, and I'm just going to grab the first port and we'll patch that into CV. Yeah, cool. Yeah, you can hear that moving the value, and just like on the other modules, there's an attenuator knob above it. If the attenuator knob is perfectly up and down, no control voltage will be allowed to modulate the fade position. As you turn it up, it allows more and more of that voltage through, and off on the left, it will actually invert it and scale it appropriately. As I mentioned at the start of the video, this module will also work with control voltage. So you can see I've added the smooth LFO to the patch. We've got the 4 outputs up here on the scope. The line in purple will be the output of the all from the crossfader. So I'm going to patch each of these 4 outputs in here into the crossfader. So down here you can see we're getting the first input signal, but we can fade between that. So I can put it halfway in between, and you can see we're kind of getting this interesting kind of angly shape coming out the bottom. We can crossfade over to number 2. We get that one. Same thing with number 3 here, and all the way over to 4. And this does, of course, work with modulation. So you can see here I am modulating the fade position using the first output from the LFO, and it's creating this interesting kind of long repeating pattern here out of the modulation. Anyways, both of those were some basic examples of what you can do, but there's a lot of interesting stuff. Modules that are simple end up being modules that actually allow quite a lot of creative possibilities. A couple of ideas for you as you think about ways to use this. One is you don't have to patch every input. You can leave some of them blank, and that will create dead space or downtime where modulation isn't happening. Another idea is to think about using the 1, 2, and the 3, 4 output in different ways. For example, if you were routing audio, you could think of 1, 2 as left and 3, 4 as right. And if this was being quickly modulated, you could create a stereo field. There's also a bunch of ways that you could use control voltage with that as well. Moving along now, we have the second module, which is called Mix Processor. Mix Processor is a bit of a multi-tool type of module. And the idea was to cram the majority of what you would need to control, manipulate, scale, offset, control voltage signal all into one small compact module. At the outset, one thing I want to make clear, this is a 2-channel module, and a channel encompasses everything from this in port to the inverted input port to this vertical slider, attenuator, CV in and out. So everything from here all the way down to here constitutes one channel. All of this is completely independent, and whatever you do on the controls above it, you will get on the output. There is an equivalent channel. It is identical. It sits over here on the right, and we'll talk about sum and max here in a second. So let's take a look at a channel. I'm going to show you on channel 1, but everything I show you applies to channel 2 as well. So I'm going to take the output here of the LFO, patch that into input 1. You notice it lights up because we like little details like that. Anyways, I'm going to patch the output here into a scope, and you can see, yes, it's the LFO that we were using a second ago. So walking through the controls here, anything that's patched to input will be used exactly as it is given. If instead you patch it to the one below, the inverted input, you will get the inverted form. Now, what I'm going to do here is I'm going to use both at the same time to let you see what I mean. The red line is channel 1 going into the regular input, and the green line is channel 2 going into the inverted input. You can see we're getting the same signal, except it's been flipped symmetrically across the 0 voltage line. All right, so that's what inverted input does. Now, by the way, you can patch both at the same time. So for example, I'm going to take a different input and I'm going to patch it here to inverted input. And what will happen is it will actually sum the two of those together. So in a way, this is kind of like a mixer where the second input just gets inverted. And yes, this does work with audio as well. Now, one quick note before we move on. If you patch the same signal into both input and inverted input, you're going to get 0. And that is because any signal added to the negative version of itself will always be 0. If you've ever heard the phrase phase cancellation, that's what this is. So just be aware of that. After these two input ports appear, we have a level slider. When you have a value coming into one of these input ports, either audio or a control voltage, then this effectively becomes an attenuation knob. Well, we say attenuation because it's control voltage. If this was audio, this would be a volume control. Down below, we have a CV port. And what the CV does is you can think of this like a VCA on this signal. There is an attenuator knob, just like all of the other modules in this series. It goes from negative 100% up to 0 over to 100%. I'm going to patch a second input here. And you can see what that's going to do is it's going to apply this control voltage to a VCA that affects this voltage here. Okay, now let's go back to that slider. You notice that when I did that, let me take it off. You see we've got the full signal here. And then when we do that, it gets kind of small. That's where this knob comes in, because as you combine and mix and smush voltages together, sometimes they can either get too big or too small. And so being able to manually set it to the level that you want becomes pretty relevant. So here, we're actually getting a really neat pattern based on that. If you're wondering, here's what number 3 looks like. And again, we can bring that down if we want. Okay, now there is another trick. If you do not have anything connected to a channel, so there's nothing coming in either of these input ports, then the output here will actually be a control voltage that is controlled by this knob. So you can see there, with nothing plugged in, the tooltips now are giving us volts, so 5 volts down to negative 5 volts. This is giving us a static volt amount. By the way, you can enter volts when you edit the tooltips as well. Now that you understand the two channels, let's take a look at the other two jacks down here, sum and max. What sum will do is it'll basically take the output of both of these and mix them together. So for example, I'm going to put this signal here into 1 and this signal here into 2. And if we take the sum, we get both of those added together. Now, max is similar. What it will do is it will always take the largest value of the two. So if you watch here, what it'll do is it'll look at these two signals, and whichever one is bigger, that's the one that you will get. Let's try this with something else. Yeah, so there you can see it's a little bit easier to see. Whatever is the largest of these two is what max will give. Now, where this starts becoming interesting, I mentioned that when none of the input jacks are connected, then this slider becomes voltage. And so here you notice something interesting, which is with channel 2's slider set to 0 volts, max will act as kind of a cutoff. So you can see we're only getting the voltage at number 1. Let me turn this up. We're getting the voltage on channel 1, and because it's taking the largest value, whenever this drops below that, it's getting dropped. Now, something that comes up fairly often when dealing with control voltages is that you may have a bipolar voltage and you want a unipolar. That is, you can see here our input signal in red. It goes from negative 5 volts up to positive 5 volts. We know that because this is the 0 line right here. And we might have cases where we only want that signal to go from 0 volts to 5 volts. In other words, we only want it to move positively. Now, this can be useful if you are doing modulation and you want to set the knob at the lowest value, and then you want your modulation to increase it only, not to decrease it. That's when you would want a unipolar voltage. Now, we can do that with the mix processor. It's going to take a couple of pieces. One, I'm going to reduce the scale of the input signal. So here on channel 1, you can see that I've dropped it down and we have a much smaller signal now here in red. Now, what I'm going to do is I'm going to add voltage to that, and I want to add enough voltage to where it comes up above the 0 line. So here you can see that at this particular setting, I've scaled the incoming voltage down to about half, and then I've moved it up. So this is only moving in that domain. If I wanted it to be a little bit bigger, maybe I wanted more modulation, I can adjust these a little bit until it, there we go, until it kind of gets to where I want. Using the combination of these two, what we're actually doing is this is called scaling and offsetting. And again, because either of these channels can do both of these functions, you can mix and match them in whatever way you would like.